problem 2, instruction A. What the problem wants us to get is the change between both of the circumstances. Being T1 the first and T2 the second, what you need to get is the increment. So what you get is y2 minus y1, which in this case is T2 minus T1, because of the values we're given. So what you do is you plug in in T1 you plug in the first value that you get for L in order to get the final result, and you do the same in the second circumstance, which is plus 0.5%, which is a difference of 0.02. So next what you get is this as an answer after you plug in. So you only have to subtract the T2 minus the T1 and you get this, which is the delta T, the exact change. Okay, so the next thing that we're asked for in the instruction B is to get the percentage of that change. So all we need to do is divide the increment that we already got. Divide the increment by T1, then multiply it by 100, and then we will get the percentage, which is 0.24968. So finally, in the next problem, in instruction C, what we need to get is the approximate percentage of change. How do we get the approximate percentage instead of the exact percentage? So what we need to do is to get the difference through differentials. So we have to get the derivative of the first formula we get, which was 2 pi square root of L over G, which G stands for 9.81. And then we get dt over dl equals pi over square root of 9.81 times the square root of L. So what we need to do next is we isolate dt and replace the L by the first value, which was 4. So after we plug in, we get dt of 0.01003, which is very similar to what we got at the beginning, the increment, but it's just an approximate. And then what we need to do is get the percentage the same way as we did in the instruction B. We divide it by the first value of t, then we multiply by 100 and we get the approximate percentage, which is very similar to the exact percentage.
The next thing we have to do is find out the approximate error in the day of the pendulum. So in order to do that, we have to calculate how many seconds there are within a day and multiply that by the rate of change which we found in number C. So what we do is we multiply 24 hours by 60 minutes by 60 seconds, and that will give us 86,400 seconds. So we multiply that by the rate of change, which was 0.984 hundredths, and that will give us 85,017.6 seconds. So what does this mean? What this means is that since the length grew about 0.02 feet, this will mean that the period will have expanded from the original time to now this new time, which is 85,017.6 tenths. So this means it will now take longer for the period than it did before.
Okay, I have to do problem number 5, and the problem is 6 over x minus x squared over 2 squared. So first, I have to do distributive property, and because it's a square, so everything multiplies everything. So it's 6 times 6, it's 36x to the minus 2, because minus 1 minus 1, it's minus 2, and then 6x times negative x squared over 2, it's negative 6x over 2, and then x squared over 2 times 6x minus 1, and then plus, because you have two negatives, x to the 4th power divided by 4. So now I integrate it, and it's x you do a plus 1, so it's x to the minus 1 over negative 1 minus 6x squared over 2 and x to the 5th power divided by 4 times 5, which is 20. So the final answer is f prime of x dx negative 36x minus 3x squared plus x to the 5th power divided by 20 plus c.
To solve this problem, we are going to use the formula of integration, which is x to the power of n plus 1 divided by n plus 1 plus c. So what we're going to do first is we're going to distribute the 14 square root of x to the rest of the terms, which is going to give us 14x squared times square root of x minus 70 square root of x divided by 2 square root of x plus 14 pi times square root of x. Next, we are going to change the square roots to powers so we can add them. So it's going to be 14x squared times x to the power of 1 half minus 35 because we simplified the previous term plus 14 pi times x to the power of 1 half. Now we're going to add them. So it's going to be 14x to the power of 5 halves minus 35 plus 14 pi x to the power of 1 half. Now I changed it to a tree because I moved a step ahead. So it's going to be 14, now we're going to integrate and it's going to be 14x to the power of 7 halves divided by 7 halves minus 35x plus 14 pi x to the power of 3 halves divided by 3 halves. Now we're going to simplify, and it's going to be 28x to the power of 7 halves divided by 7 minus 35x plus 28 pi times x to the power of 3 halves. All of this divided by 3. Next we are going to use the proper notation, which is the symbol of integration f of x dx, and simplify, which is going to be 4 square root of x to the 7th power minus 35x plus 28 times pi square root of x to the 3rd power divided by 3 plus c.